Hello friends, welcome back to our channel. So today we'll see one more concept in R programming, that is operators. So R programming supports different kinds of operators. So we will see the first one, arithmetic operators, relational operators, logical operators, assignment operators, and miscellaneous operators. So all these operators can be implemented for two things. One is on variables, on vectors. So we have seen in our previous video what is a vector, right? So it holds the complete multiple elements of same data type, right? So we can apply these operators on vectors or on variables. So if you apply these operators on vectors, the result will be in the form of a vector. I mean, vector means the operator will be implemented for each and every element of the vector. So we know that arithmetic operators: addition, subtraction, multiplication, and division, right? So apart from these, a few more operators are included in this arithmetic operators, which is mod, which gives the remainder, and so this mod is represented as a double percentage, and this is a which gives the quotient as a result, quotient. And one more thing is an exponent. So if you go with the example, I will give an example. Vector, let us take some vector a 1 2 3, b is also vector, some 4 5 and 6, right? So if you go with the a plus b, the result will be 1 plus 4, it will be 5, 2 plus 5, it will be 7, and 3 plus 6, it will be 9. So it will add complete individual elements of the vector. So if it is a normal vector, if it is 10 and b is equal to 20, obviously a plus b will get it as a 30, right? So if it is a vector, the operation will be applied for individual elements of a vector, right? So don't worry, just I'll give you the introductory part now, and we'll see the implementation in the R Studio, right? So we know that subtraction, that's a difference, multiplication, which product, division, which gives the accurate result, right? Accurate result. And this is a mod, which gives a remainder as a result. Remainder, right? Remainder of the after the division operation. So if you apply the division operation, we'll get a remainder and quotient. So this is the remainder, and this will be the quotient, right? For example, if 3 is divided by 2, so 2 ones 2, right? So this will be the remainder, this will be the quotient. So if 3 double mod 2, that means 3 is divided by 2, the remainder will be 1, and 3 divided by 2, which gives a quotient, which is again 1, and 3 divided by 2, which gives it as a 1.5. So this is the difference. And exponent is nothing but a power. So for example, a is equal to 2 and b is equal to 2 or 3, and a cap b, which gives it as a 2 power 3, right? Which gives a 8 as a result. So this is the exponent, and all these operators comes under arithmetic operators. So we call them as a arithmetic operators. And we'll see the implementation part in R Studio system, right? So next go with the relational, so which gives a comparison between different operators, I mean different variables or vectors, and also it will result Boolean It will give the Boolean result, right? Boolean result means either it will be either true or it will be false. It will be either true or false. So this can also be used in between the vectors and the variables. So for example, a is equal to some c, 10, 20, 30, and let it be b is equal to some c of 100, 10 and 40, or simply you can go with the 30, right? So you can see a, first we'll see the operators less than, greater than, less than or equal to, greater than or equal to, double equal to and not equal to. So all these comes under the comparison operators, or we call them as a relational operators. So if you go with the a less than b, the result will be 10 less than 100. So obviously it will return true. 20 less than 10, it is a false. And 30 less than 30, again it will be a false. So the result will be in this way. The result will be in this way, right? It will return true or false, right? So it will compare each and every element, it will return true or false. Otherwise, if you are applying the same relational operators in between the variables, directly we will get only single value, that is either true or false. For example, a is equal to 10 and b is equal to 20. If you go with the a not equal to b, which gives the result as true, because it is only a single value. It is a single value, right? So which compares the value of a variables or a vectors is called as a relational operators. So comparisons will be done. And next category of operators are the logical operators. So here we'll get AND, OR, NOT, double ampersand and double OR, right? So usually all these comes under the logical operators. So here mainly non-zero value will be considered as a true and zero value will be considered as a false. Zero value will be considered as a false. So here also the comparison will be done, okay? And if n, if both are true, so if it is n, both are true, then only the result will be true. And or both are false, both inputs are false, then only it will get a false. If any one of the input is true, automatically it will be returned true. And not if true, it will return false, and if it is false, it is a true. Right? So, and these two operators will be used in compound conditions. Compound conditions. So here, what is a compound condition means? Comparing two simple conditions. Comparing conditions. So in comparing conditions, we are going to use this double AND and double OR. For example, A greater than B, A greater than C. If you want to compare these two, so we need to use this double ampersand. So we'll get a Boolean result for this condition and Boolean result for this condition. So for those results, we'll apply the AND operation. So if both are true, then only we'll get a true. If both are false, it will be false. So similar to single ampersand and single OR. But here we'll use this double ampersand and double OR for compound conditions, comparing different conditions, right? So I'll show you an example in our studio, right? Don't worry about that. But here one thing we have to remember, non-zero will be considered as a true and zero will be considered as a false. Assignment operators, we have seen the assignment operators in our second video, I think, is equal to assign a value to a variable and right word, left word. So using all these things, we can assign a value. So A is equal to 10, A 10, right? So in all these three cases, 10 is a value stored in a variable A, right? So these are all called as an assignment operators. And last one is a miscellaneous operators. Here three miscellaneous operators are there. So those three miscellaneous operators are a colon, so which gives a range of values, which specifies the range, right? And ampersand in ampersand. This is for search, and one more is a star, which gives the product of matrix with its own transpose. It gives a product of, it will be used for a product of matrix with its own transpose, or else it will give sum of products in a vector. I'll explain you one by one, right? So coming to the range, so these three we call it as a miscellaneous operators. Range means we can give a is equal to 1 to 5. That implies a can hold values 1, 2, 3, 4 and 5. So we can specify a range instead of giving a single value. Search. So if you are using this particular range, we can search whether any variable is available in that particular range or not. For example, if you go with a b is equal to 4, you can search, so b in a. So if b value is available in a, it will return true, otherwise it will return false. So again here the result is Boolean result, right? So this is for search, right? So the operator is percentage in percentage, and this is a product, I mean matrix with its own transpose, product of matrix with its own transpose. For example, if it is a vector, let us take a vector so that you will be understanding. B is equal to, again one more vector, so 2, 3 and 4. So if you go with A and into B, we will get 1 into 2, 2 into 3, 3 into 4. If you go with this miscellaneous operators, star in between star in between the percentage symbols, so it will give us 1 into 2 plus 2 into 3 plus 3 into 4. So which gives us a 2 plus 6, 8 plus 12, 20 will be the result. 20 will be the result. So it will give the sum of products. So this is the first element, this is the second element, this is the third element. So we are adding all these three elements. So sum of products of elements in a vector. So this is the third miscellaneous operator, right? So hope you understood this. So these are all the operators which are supported in R programming. So arithmetic operators, relational operators, logical operators, assignment and miscellaneous operators. So other programming languages also the same operators will be used, but some sort of representation will be different. The symbols to represent the operator will be changing from one language to another language, right? So hope you understood. So let's move on to the R Studio, so that I'll implement each and every operator and I'll explain, so that if you are still having any queries, so everything will be cleared after watching the implementation part. Let's move on to the R Studio. Hello friends, so just now we have seen the complete theoretical part of different operators which are available in R programming. Now we'll see the execution or implementation part, right? So let me open the R Studio, so where we are going to write down the programs and execute them. So yes, let me clear all the things which are already available. Now we can start. So we have seen a different operators in that are supported in R programming. So first one is arithmetic operators. In that operators we have seen addition, subtraction, multiplication, division, and one more thing, a mod, so which is represented with a double percentage, and quotient. So quotient is represented with a percentage / percentage, and then exponent operator. right? We'll see one by one. So we know that arithmetic operators, and these operators can be implemented on individual variables or the complete vectors, right? So let us take a is equal to 10, a sorry, a is equal to 10 or 20, and b is equal to some 30, and you can simply go with a print a plus b. So it will be executed, and see, you will get the result as a 50, right? So normal arithmetic addition, this is called an arithmetic addition. So the same thing happens if you apply on vectors also. Now we'll see the vector. So vector is represented with the c followed by the parenthesis and give the number of values. So 10 comma 20 comma 30, three elements, and let us take here c of let us take some 40, 50 and 60. And if you apply the same thing in between the vectors, so previously we have seen the only normal variables, right? So now execute, and now you can see the result is 50, 70, 90. So the individual elements of A and B are added, and it will be printed on the screen. So 10 plus 40, 50, 20 plus 50, 70, 30 plus 60, 90. And here you can see in the environment, the A value holds the three values, because it is a vector, 1 column 3, so that means 1 2 and 3, so which is a 10 20 30 40 50 60. And the same thing, so this is all about our addition. And similarly subtraction, so normally we can go with the subtraction with the normal variables. So let us take some normal variables. Some m is equal to 30 and n is equal to 20, and once again I will go with the a minus b, right? So here a and b are the vectors, and m and n are normal variables. Let us execute. And you can observe here a, b are the vectors and m and n are variables, right? So a minus b, so 10 minus 40 is minus 30, 20 minus 50 is a minus 30, and 30 minus 60 is a minus 30. And m minus 10 again, that means 30 minus 20 it's a 10. So the subtraction, so all these operators can be applied in on either vectors or a normal variables. And coming to the multiplication, that is also common, so which we are using in our daily life. So see, execute, see 10 into 40, 20 into 50, 30 into 60, and similarly 30 into 20, 30 into 20. So this is a normal multiplication. And coming to the division, so you'll get the complete accurate result, right? So accurate result. So if you execute, see 10 divided by 40, which is a 0.25, 20 divided by 50, which is a 0.40, 30 divided by 60, which is a 0.50, right? So and here 30 by 20, it's a 1.5. So these are all normal arithmetic operators: addition, subtraction, multiplication, and the division. And now we'll go with the mod operator. So we'll see the mod, so which is represented with a double mod, right? Which will give the remainder, which will give the remainder of a value, right? So let us execute and see the remainder. What is the remainder? 10 mod 40, which is a 10, 20 mod 50, which is a 20, 30 mod 60 is nothing but 30. So because, so here this is a lower value. If you use some b and a, see 40 divided by 10, which is 0, that means remainder 0, and 50 divided by 20, the remainder is 10, right? So 22 is 40, so and the remainder is 10, and 60 mod 30, which is 0. So we'll get the remainder as a result. What is the remainder? And coming to the normal variables, you can see 30 and 20. So 30 mod 20. So 20 ones are 20, the remainder will be 10, right? So that's why we got the result as a 10. Now, coming to quotient. If you want to get the quotient, so this is a reminder, okay? So this is a reminder, and now we are talking about the quotient. So that is represented with a percentage divided by n percentage. Now I'll show you. So this is the quotient. See, 40 divided by 10. So automatically 10 4s are 40, so the quotient is 4. And 50 divided by 20, because B divided by A we are giving, not A divided by B, right? 50 divided by 20, so 22s are 40, so 2 will be the quotient. 60 divided by 30, again 2. And 30 divided by 20, and the quotient is 1. So we'll get only the quotient, that is also in integral part. Right? So hope you understood. Now we'll see the next one, that is a exponent operator. So let us take some 2, 3, 4 and 4, 3, 2, and let us take it as a normal exponent operator A cap B. Cap exponent, that means A power B. Oh, sorry. 3, 1 A cap B, right? So let us execute. Now you can see A cap B, 2 power 4, which is 16, 3 power 3, which is 27, and 4 power 1, which is a 4. And similarly 3 power 2, that means a 3 square, which is 9. So all these are the arithmetic operators. Now we will move on to the next one, that is a relational operator. So this is nothing but comparison operators, which is less than, greater than, less than or equal to, greater than or equal to, double equal to, not equal to. So all these things will return Boolean result. So what is meant by Boolean result? Either it will return true or it will return false, right? So here I'll write here, so A greater than B, and here also I'll go with the M greater than N. It will compare each and every element of different vectors and it will return the result. See, you can observe. See, 2 greater than 4, it's a false. 3 greater than 3, it's again false. 4 greater than 1, it's a true. And 3 is greater than 2, it's a true. So it will return either true or false. Okay, and similarly, the less than, all these relational operators will work in the same manner. So it can be used in both the normal variables and the vectors. So here 2 less than 4 true, 3 less than 3 false, 4 less than 1 false, 3 less than 2 false. And if you go with the is equal to, again you will get the same Boolean result. Right? And also is equal to. See. Okay, so the complete relational operators and everything, if the operator is used in between the vectors, it will result with an individual operator, individual element of the vector, right? Next, after the relational operators, we'll go with the next one, that is the logical operators. So one is AND, OR, NOT, and logical AND and logical OR. So there is a slight difference between this single ampersand and double ampersand, right? So that comes with the normal, I'll show you. So if you use the same thing, so go with the A ampersand B, that means AND. So we know that just now we have seen AND means if both the inputs are true, then it will result true. So here what is a true? Here true means a non-zero value will be true and 0 will be false. So any non-zero value we can consider as a true. So here 2 is a true, 4 is true. So let us take one more thing which is a false. We can also take that one, right? So because it's also one data type. I'll go with the true, right? Now you can observe, see, 2 is a true, and 4 is true. So it gives true. 3, 3, true, true, true. 4, 1, true. False and true. So false. Because if both the inputs are true, then only it will return true. Otherwise, it will return false. So we can change it here 0 and I'll change here 0. Now you can observe here. See, 2 and 4 both are non-zeros, so true. 0 and 3 false and true, false. 4 and 0 false, false and true, false. So non-zero value will be considered as a true and a zero value will be considered as a false. And also we can directly take the Boolean data types. Okay, and m and n. So here m is 3, which is a non-zero true. N is 2, which is non-zero true. So if you apply the AND operation, we'll get the result as true. And if you apply the OR operation, so we know that OR operation means if both are false, then only it will be false. If any one of the input is true, the result will be true. Right? So if you execute with the OR operation, so take the same example and apply the OR operation. So here 2 and 4 both are non-zeros, we'll get a true. And 0 and 3, that means a false and true. So if any one of the input is true, the result will be true. So obviously the second one will get true. And 4 and 0, again it will get true. True and false, again we will get true. See, you can observe true, 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 true. And here also we'll get true. I'll change here 4 as 0. And now you can see the third element of both the vectors are having the false. Now you can see, if both the vectors are false, automatically the result will be false. So this is about the logical AND and OR operators, right? And this again, similarly we are having one more, that is a double ampersand and double OR. So if you use a double AND, so two ways. If you are applying the double ampersand in between two different vectors, it will compare only the first element of both the vectors. If the first element of both the vectors are true, then it will return true, or it will return false. It doesn't compare each and every element of the vector, right? See, you can observe. Okay, so right, so and next one is a not. So that means, see, this not. So not is for negation. That means if the input is true, then it will be returning false. If it is false, it will return true. That means it will take only one argument. That means one operand. So A not B is not correct, not A is correct. And here also not M. Now you can see 2 means a true, 0 means false, false, false. And if you execute, we'll get a false, true, true, true. Because this is true, so it becomes false. These three are false, so it becomes true. And here also M is 3, we'll get a false. If M is 0, we'll get it true. Right? So this is how we can use the AND, OR and negation. And coming to this ampersand, double ampersand and double OR, these are used for a logical condition. So if you want to check multiple conditions, then we can use these AND and OR operators, multiple conditions, right? So that means, let us take here M greater than N and P greater than Q. Let us take P is equal to 10, Q is equal to 2. Let us remove all these things and execute. So you'll get a false because M greater than N. So this is a compound condition. Okay, this we call it as a compound condition, right? So compound condition means we comparing two different conditions. So M greater than N. So 0 greater than 2, false. So if any one of the condition is false, automatically we'll get a false because we are using double ampersand. For example, if you take here 20, then it will result as a true because m greater than n, that means 20 greater than 2, true. P greater than q, 10 greater than 2, it's again true. True and true, true. So like that in the compound conditions, we are going to use these logical operators. And the next one, assignment operators. Assignment operators. So this we have already used all these things, assignment operators. So one is equal to, or we can also use right word, and we can also use left word. Okay, so by using all these things, we can use assignment operators to assign a value. So all these assignment operators we have already covered because in all these cases we are using the same thing, right? Assignment, without assignment we can't assign a value to the variables, right? And here there are a few more operators. Those are called as a miscellaneous operators. Miscellaneous operators. Mainly there are two miscellaneous operators. So one is a colon, which gives a range of values, and another one is a in, so which will be used for searching for a value, and one more is a star, right? So three operators, we call it as a miscellaneous operators. Let us check with this one. So let us take some some a is equal to, I'll give it a 1 with 10. 1 is to 10. So here colon is a one miscellaneous operator which will give the range. So this line indicates, this instruction indicates, so a holds the values from 1 to 10. And now you can see print a. See, a will be having the values with 1 to 10. So this is one miscellaneous operator which will give the complete range of values. And similarly, one more thing, that is a in. So b is equal to some 5. We can search this 5 whether this particular b value is available in this given range a. So for that we can go with a b in a. So search, if it is available, it will return true, otherwise it will return false. You can see it is true. And if you go with a 50 and execute, so 50 will be not available in from 1 to 10, so it will give false. So this replaces the search. If we are searching for a value in a complete sequence, obviously we can go with this particular operator called in operator. In operator, right? So, and also you can see, let us take some vectors 10, 20, 30, and b is equal to 1. Just for better understanding, I'll see c is equal to 1 comma 2 comma 3, and here also we'll take small values 3 to 1, right? And now yes, here it is a vector, so it should start with c, and here the operator is a star operator b. Now what happens, you can observe what happens here. See, this gives the product and sum. So 3 into 3, sorry, 3 into 1 plus 2 into 2 plus 1 into 3. Okay, so you can observe 3 into 1, it's a 3, plus 2 into 2, it's a 4, plus 3, 7, 3 into 3, 3 into 1 into 3, again 3, right? So this gives some 3 into 1, sorry, 3 into 1 plus 2 into 2 plus 1 into 3. So obviously we'll get the result as 10. Usually this operator is mainly used to multiply a matrix with its own transpose. Multiplying a matrix with its own transpose. For that purpose we are going to use this operator called a star. So usually if you take these percentage symbols, then it will execute, it will be treated as a normal multiplication. So 3 into 1, 2 into 2, and 1 into 3. And if you use a mod, in between a mod, then obviously it will be considered as a sum of products. Okay, sum of products. So 3 into 1 plus 2 into 2 plus 1 into 3. So obviously we'll get a 10. Right? So all these are the different operators. So we have seen arithmetic operators, relational operators, logical operators, assignment operators, and miscellaneous operators. Right? So hope you understood. And if you are having any doubts regarding these operators concept, feel free to post your doubts in the comment section. Definitely I'll try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.